Today we are going to talk about quicksort. Quicksort is a fundamental concept in computer science. Like sorting is a fundamental concept in computer science, and one of the most efficient algorithms for sorting is quicksort. In this video, I will explain how quicksort works, provide an example, discuss it in its time and space complexity, and shows us implementation in Python. Now, how Quicksort works. Quicksort follows these steps. First, Quicksort chooses a pivot element. It can be any last, first, or middle element, and partition the array. After choosing the pivot element, we partition the array into two subarrays. It is left subarray and right subarray. And after, like, elements smaller than the pivot goes to left, and elements to greater than pivot element goes to right. And after partitioning the arrays, we recursively apply quicksort on left and right subarrays. Best case, if any array has one or no elements, returns example. Now we talk about an example. Here sorting array, the elements are 8, 4, 7, 3, 9, 1 and 6. Here is an array, and we choose 6 as our pivot element. And now you can see the elements lesser than 6 are goes to left subarray, and the elements greater than the pivot element goes to right subarray. And after we recursively apply sort the left and right subarrays, here is the result. And finally we merge the both arrays and we get the final result. Now we talk about the main thing here, time complexity breakdown. Best and average case, O of n log n. O of n log n. Now we talk about it more precisely. Best case and worst case is O of n log n. Each partition step divides the array into nearly 2 equal halves, and the depth of the recursion is log n because the array keeps getting divided into half. Here the arrays keep recursively divided into half, so the complexity is log n. Since they are log n level and n operations per level, here we have log n levels and n operations per level, so the total time complexity is O n log n. Here you can see it. So now let's talk about worst case. If pivot element is always the smaller or largest, so it one side remains empty, leading to n levels of recursion instead of O. Here, if the pivot element is smallest or largest, the array is not divided into two halves. Instead, it has n, so it will have n levels as well as n operations per level. Each level processes n elements, making it n square, O of n square, which is not ideal for anything. Example 1, 2, 3, 4, 5, 6. Here you can see an array and the pivot element is 6. We take pivot element as 6. So the left subarray will be 1, 2, 3, 4, 5, 6, and right subarray will be empty. So it takes O of n square for completion of operation. Now we talk about space complexity breakdown. Quicksort is in place means it does not use extra space, unlike merge sort. In merge sort we need extra space for allocating the arrays. So unlike the merge sort, quicksort does not use any extra space, but in merge sort it will take some extra space to perform the operations. However, it uses recursion which takes place on a call track. Instead of taking extra space, it uses recursion technique for making up the space. The best case of space complexity is log n, and the worst case is O of n if the pivot element always causes one-sided recursion. It is also linked to the worst case time complexity. Hence, time complexity is O of log n is the best case and O of n is the worst case. Conclusion: Quicksort is highly efficient sorting algorithm with an average time complexity of O of n log n. O of n log n we can derive it as theta of n log n. Worst case occurs when partitioning is unbalanced, leading O of n square, but this can be improved using better pivot selection. If we select the pivot element betterly, then we does not concern about this O of n square time complexity and space complexity also. It is widely used. It is main sorting technique which is used very highly for real world application due to its in-space sorting capability and efficiency. Due to its not taking extra space. So now here is an example. Now we go through this example. Here is the output for this example. So that's all for today. Thanks for watching.